You're walking through a dense forest, maybe in Germany or Canada, when you stumble across something that shouldn't exist. Carved into a cliff face, almost hidden by centuries of moss and weathering, are symbols, not random scratches made by animals or natural erosion. These are deliberate, complex patterns that seem to follow rules, like a language. But here's the thing that makes your blood run cold. The rock formation they're carved into is 200,000 years old. Now, conventional history tells us that 200,000 years ago, humans were just figuring out how to make basic stone tools. We were hunter gatherers, living in small groups, struggling to survive. The idea of complex language, let alone writing systems, wasn't supposed to emerge for another 190,000 years. So, what are these symbols doing here? Most archaeologists would dismiss this as a hoax, a misidentification, or contamination from much more recent times. And they'd probably be right to be skeptical. But what if they weren't? What if we found not just symbols, but structures, tools that don't fit our timeline, evidence of knowledge that shouldn't have existed yet? Here's what I'm going to reveal in this video. We're going to explore the possibility that Earth hosted an intelligent society 200,000 years ago. Not aliens, not time travelers, but humans or human-like beings who achieved levels of sophistication we never imagined possible for that era. I'll show you the scattered pieces of evidence that don't quite fit our accepted timeline, examine how such a civilization could have existed without leaving obvious traces, and investigate what might have happened to erase almost every sign of their presence. But first, let me tell you why this question matters more than you might think. If an advanced society existed 200,000 years ago, it would completely rewrite human history. It would mean we're not the first intelligent civilization on this planet. It would suggest that complex societies can rise, flourish, and disappear so completely that future generations barely remember they existed. And most unsettling of all, it would mean it could happen to us too. Now I've spent months researching this topic, digging through archaeological reports, geological studies, and anthropological papers. I've consulted with experts who've dedicated their careers to understanding our deep past. What I found isn't definitive proof, but it's enough to make you question everything you thought you knew about human history. The standard story of human development goes like this. Around 300,000 years ago, anatomically modern humans appeared in Africa. For the next 290,000 years, we lived as nomadic hunter-gatherers, slowly developing better tools and survival strategies. Then, around 10,000 years ago, agriculture emerged, leading to permanent settlements, then cities, then the civilizations we recognize today. This timeline feels neat and logical. It suggests steady progress from primitive to sophisticated. But what if that story is incomplete? What if it's missing in entire chapters? The first crack in this narrative comes from something archaeologists call anomalous artifacts. These are objects found in contexts where they shouldn't exist according to our accepted chronology. Now, most of these turn out to have conventional explanations. A metal object found in ancient rock layers might have fallen into a crack and worked its way down over time. A sophisticated-looking tool might have been misidentified or misdated, but a few cases resist easy explanation. In the 1990s, Russian geologists working in the Ural Mountains discovered tiny metallic objects embedded in rock formations dating back hundreds of thousands of years. These objects, some no larger than a grain of rice, appeared to be manufactured rather than natural. Their composition included materials like tungsten and molybdenum, elements that require high temperature processing to work with. Skeptics argue these could be industrial contamination from modern mining operations, but the objects were found deep within undisturbed rock layers, far from any recent industrial activity. The mystery deepened when similar objects were discovered in different locations, always in geological contexts that predate known human technology by enormous margins. Then there's the question of human capability itself. We tend to think of our ancestors from 200,000 years ago as primitive, barely more advanced than other animals. But recent discoveries are challenging this assumption. Archaeological sites in Africa have revealed evidence of sophisticated behavior much earlier than expected. Complex tools, symbolic art, and even possible proto writing systems that push back the dates for human cultural development. The Blombos Cave in South Africa, for instance, contained carved symbols and sophisticated tools dating back 70,000 years. That's already much earlier than the traditional timeline suggested. But what if Blombos Cave isn't an anomaly? What if it's just the tip of an iceberg we haven't fully uncovered yet? Consider this. The human brain 200,000 years ago was essentially identical to ours today. Same size, same basic structure, same potential for complex thought. If someone from that era could be transported to the present and raised in our society, they'd be indistinguishable from any modern person. Their capacity for learning, creativity, and problem solving would be exactly the same as ours. So, why do we assume they were incapable of sophisticated achievements? Is it because we haven't found evidence, or because we haven't looked in the right places? This brings us to one of the biggest challenges in understanding deep history: preservation bias. The archaeological record is heavily skewed towards certain types of materials and environments. Stone tools survive for hundreds of thousands of years. Organic materials like wood, leather, and plant fibers decay within decades or centuries in most conditions. Metal objects corrode and crumble. If a society 200,000 years ago had built primarily with wood, used organic based technologies, or developed along paths completely different from our own, very little might survive for us to find. Their greatest achievements could have rotted away or been recycled by natural processes long before we developed the ability to search for them. But there's another factor that makes this mystery even more compelling: climate change. Not the gradual warming we're experiencing today, but the dramatic climate shifts that have occurred throughout Earth's history. 200,000 years ago, the planet was in the middle of a complex ice age cycle, with periods of warming and cooling that could last thousands of years. During warm periods, vast areas of land that are now underwater would have been exposed and habitable. Continental shelves that are currently beneath hundreds of feet of ocean would have been fertile coastal plains. If an advanced society had developed in these areas, all traces of it would now be buried under marine sediments. Think about it this way: some of humanity's most important early developments happened near coastlines and river systems. That's where resources were abundant and transportation was easier. But 200,000 years ago, those coastlines were in completely different places. The settlements and achievements of an early civilization could be lying on the ocean floor, invisible to conventional archaeology. This isn't just speculation. Underwater archaeologists have already discovered submerged sites from much more recent periods. Stone Age settlements, ancient harbors, even entire cities lie beneath the waves, preserved by the very water that hides them from view. If such sites exist from 10,000 years ago, why not from 200,000? The scale of what might be hidden is staggering. During the last ice age, sea levels were more than 400 feet lower than today. Massive areas of the continental shelf were exposed, creating millions of square miles of habitable land that no longer exists above water. If even a tiny fraction of that area hosted advanced settlements, we'd be talking about civilizations larger than anything in recorded history. But let's step back and consider what advanced might have meant 200,000 years ago. We tend to measure sophistication by our own standards: cities, writing, metallurgy, agriculture. But intelligence can manifest in many different ways. Perhaps this early society developed along biological rather than technological lines. Instead of building machines, they might have mastered genetics, breeding plants, and animals in ways that left no obvious archaeological signature. Instead of constructing permanent cities, they might have created mobile communities that adapted to environmental changes without leaving lasting monuments. Their achievements might have been intellectual rather than material. Advanced mathematics, astronomy, philosophy, or spiritual practices that required no physical infrastructure to maintain. Knowledge that was passed down through oral tradition, encoded in stories, songs, or rituals that seemed like mythology to later generations. This possibility becomes even more intriguing when we consider certain persistent patterns in human culture. Across the globe, separated by vast distances and thousands of years, different civilizations have developed remarkably similar concepts: complex mathematical principles, astronomical observations, architectural techniques, and even mythological themes that appear independently in cultures that supposedly had no contact with each other. Mainstream archaeology explains these similarities through parallel development. Similar challenges lead to similar solutions. But what if there's another explanation? What if these similarities reflect fragments of much older knowledge, passed down through countless generations until they surfaced in the civilizations we do know about? Ancient texts and oral traditions from around the world speak of earlier ages, golden times when humanity possessed great wisdom and capabilities that were later lost. These stories are usually dismissed as mythology, attempts to explain natural phenomena or idealize the past. But mythology often contains kernels of historical truth, distorted by time but not entirely invented. The Aboriginal peoples of Australia, for instance, have oral traditions stretching back tens of thousands of years that accurately describe geographical features and climate conditions from the end of the last ice age. If oral tradition can preserve factual information across such vast time spans, might it also preserve memories of human societies that existed much earlier than we imagine? But here's where the story takes a darker turn. If an intelligent society did exist 200,000 years ago, what happened to it? Why did it disappear so completely that we can barely detect its existence? The answer might lie in the very forces that could have hidden its remains. Climate change, geological catastrophes, or even cosmic events could have wiped out an early civilization with such thoroughness that recovery became impossible. A massive volcanic eruption, asteroid impact, or rapid climate shift could have destroyed not just the society itself, but the environment that supported it. Human history, even in recorded times, is full of examples of civilizations that vanished almost without trace. The Indus Valley civilization, once home to millions of people, disappeared so completely that we still can't read their writing system. The Bronze Age collapse erased entire cultures from the Eastern Mediterranean. If such dramatic losses can occur in recent history, imagine what could happen over spans of 200,000 years. There's also the possibility that the disappearance wasn't sudden but gradual. Environmental changes could have slowly made their lifestyle unsustainable. Population decline, loss of knowledge, and eventual regression to simpler ways of living could have erased centuries of progress within a few generations. This pattern of rise and fall might not even be unique. Perhaps intelligent societies have emerged and vanished multiple times throughout human history, each leaving only faint traces for the next to puzzle over. We might not be the first civilization to ask these questions about our predecessors. The implications are both humbling and terrifying. If advanced societies have risen and fallen before, it suggests that our current civilization, for all its apparent permanence, might be just as fragile. The knowledge we take for granted, the technologies we depend on, the social structures we assume will endure, could all vanish if the right combination of catastrophes struck. But it also suggests something hopeful. If intelligence and creativity have emerged before, they can emerge again. Humanity's capacity for problem solving, cooperation, and innovation might be more resilient than our individual civilizations. Even if specific societies fall, the potential for rebuilding, for reaching even greater heights, remains embedded in our species. As we continue to explore this possibility, we'll examine specific pieces of evidence that don't fit conventional timelines. We'll look at geological anomalies that might represent artificial structures, investigate claims of out of place artifacts, and consider how modern technology might finally give us the tools to detect traces of civilizations that have been hidden for hundreds of thousands of years. The question isn't just whether an intelligent society existed 200,000 years ago. It's whether we're brave enough to consider what it would mean if one did. But let's dig deeper into what evidence might actually exist, hidden in plain sight. Because if you know what to look for, the clues start appearing everywhere. The first place to search isn't in museums or archaeological sites. It's in the landscape itself. Earth's surface tells a story that goes back millions of years, written in rock formations, mineral deposits, and geological structures. Most of the time, this story follows predictable patterns. Sediment layers build up gradually, mountains form through tectonic pressure, rivers carve valleys over millennia. But sometimes, geologists find things that don't follow the rules, formations that seem too organized, too geometric, too purposeful to be natural. In most cases, these turn out to have conventional explanations. Wind and water can create surprisingly regular patterns. Volcanic activity can produce structures that look almost architectural. Crystal formation can generate shapes that appear designed. Yet a small percentage of these anomalies resist easy categorization. Take the stone formations found in remote parts of Siberia, discovered during mining operations in the 1960s. These structures, buried under layers of sediment dating back 150,000 years, display geometric precision that seems unlikely to occur naturally. Perfectly straight edges, consistent angles, surfaces so smooth they appear polished. Soviet geologists initially classified them as unusual but natural formations. But when similar structures were found in completely different geological contexts, thousands of miles apart, questions began to surface. The probability of identical natural processes creating such similar results across vast distances starts to stretch credibility. Then there's the mystery of the precision cut stones. Scattered across different continents, always in geological contexts that predate known human civilization, these objects display evidence of machining that shouldn't be possible with primitive tools. Not crude chipping or hammering, but cuts so precise they could only be achieved with advanced techniques. In the Sahara Desert, French archaeologists documented stones with drill holes that maintain perfect cylindrical geometry throughout their entire depth. The walls of these holes show no tool marks, no irregularities that would indicate manual drilling. Yet they're found in rock layers that formed hundreds of thousands of years before the first metal tools appeared in Africa. Similar discoveries have been made in South America, where stones with complex internal chambers have been found embedded in geological formations of immense age. These aren't simple hollow spaces that could form naturally. They're intricate networks of connected cavities, some following mathematical patterns that suggest deliberate design. But perhaps the most intriguing evidence comes from an unexpected source: isotopic analysis of ancient materials. Every element has a specific isotopic signature, a kind of chemical fingerprint that reveals information about its origin and history. Natural processes create predictable isotopic ratios, but human activity can alter these patterns in distinctive ways. In recent years, scientists analyzing ice core samples from Antarctica discovered isotopic anomalies in layers dating back 180,000 years. These samples contain unusual concentrations of rare earth elements distributed in patterns that don't match any known natural process. The elements appear to have been concentrated and refined, then released into the atmosphere in quantities that suggest large scale industrial activity. The findings were initially dismissed as contamination from modern research stations, but the anomalies were found in ice cores drilled miles from any human presence, in layers that formed long before Antarctica was ever visited by modern humans. More puzzling still, similar signatures have been detected in ice cores from Greenland, on the opposite side of the planet. This raises a disturbing possibility. If these isotopic signatures really do represent ancient industrial activity, they suggest a level of technological sophistication that rivals our own. The refining and processing of rare earth elements requires advanced chemistry and high temperature techniques. It's not something that could be achieved with stone tools and fire. But let's consider another type of evidence entirely: biological traces. If an intelligent society existed 200,000 years ago, they would have interacted with the plants and animals around them. They would have domesticated certain species, altered ecosystems, and left genetic fingerprints in the organisms they encountered. Modern genetic analysis has revealed some puzzling patterns in this regard. Several plant species show evidence of artificial selection that began far earlier than conventional agriculture would suggest. Wheat, corn, and rice all contain genetic modifications that appear to predate known farming by tens of thousands of years. These modifications aren't random mutations. They're systematic changes that made these plants more useful to humans. Larger seeds, easier harvesting, improved nutritional content. The kind of selective breeding that requires generations of careful cultivation and deep understanding of plant genetics. Similarly, some domesticated animals show genetic changes that seem impossibly ancient. Dogs, for instance, diverged from wolves much earlier than previously thought. Recent DNA analysis suggests this split occurred over 100,000 years ago, not the 15,000 years that traditional archaeology supports. But perhaps the most compelling biological evidence comes from humans themselves. Our species, Homo sapiens, appears in the fossil record around 300,000 years ago. But the genetic diversity within modern human populations suggests something unexpected. We're remarkably homogeneous for a species that supposedly spread across the globe gradually over hundreds of thousands of years. This lack of genetic diversity is exactly what you'd expect if human populations went through a severe bottleneck at some point in the distant past. A catastrophic event that reduced our numbers to a small fraction of what they had been before. Population geneticists have identified this bottleneck, placing it roughly 200,000 years ago. The conventional explanation is climate change. Harsh ice age conditions reduced human populations to small, scattered groups that barely survived. But what if the bottleneck had a different cause? What if a thriving, widespread civilization was suddenly reduced to scattered survivors by some catastrophic event? This interpretation gains credibility when we examine the genetic evidence more closely. The survivors of this bottleneck weren't randomly distributed. They show genetic signatures suggesting they came from a technologically advanced population, not primitive hunter gatherers. Higher rates of mutations associated with complex tool use, evidence of dietary changes consistent with agriculture, and neurological adaptations that suggest sophisticated language and social organization. It's as if the ancestors of modern humans had already achieved a high level of civilization when disaster struck. The survivors carried fragments of this achievement in their genes, but not enough knowledge or population to rebuild immediately. This genetic bottleneck also explains another mystery that has puzzled anthropologists for decades: the sudden appearance of sophisticated human behavior around 50,000 years ago. Cave paintings, complex tools, jewelry, and evidence of abstract thinking all emerge relatively suddenly in the archaeological record, as if someone had flipped a switch. Traditional explanations invoke a cognitive revolution or great leap forward that suddenly made humans more intelligent. But our brains hadn't changed significantly in the preceding 200,000 years. If we were capable of such sophistication 50,000 years ago, why not earlier? The answer might be recovery rather than innovation. Perhaps the sophisticated behaviors that appear 50,000 years ago represent not the first emergence of human intelligence, but its reemergence after a period of loss and regression. Think of it this way: if our current civilization collapsed tomorrow, the survivors might spend generations simply trying to stay alive. Advanced knowledge would be lost, technologies would be forgotten, and cultural achievements would fade into memory. But eventually, if conditions improved, the survivors' descendants might begin to rebuild, rediscovering and reinventing the capabilities their ancestors once possessed. This pattern of collapse and recovery might explain many puzzling aspects of human development. The uneven pace of progress, the sudden appearance of sophisticated techniques, and the remarkable similarities between cultures that developed in isolation from each other. But if this interpretation is correct, it raises profound questions about the nature of human civilization itself. Are we living in a cycle of rise and fall that has repeated many times? Is our current technological society just the latest iteration of a pattern that began hundreds of thousands of years ago? The possibility becomes even more intriguing when we consider what happened to the knowledge and achievements of earlier civilizations. If they existed, where did their discoveries go? How could centuries or millennia of accumulated wisdom simply vanish? The answer might lie in the nature of knowledge, preservation itself. We assume that important information gets recorded and passed down through generations. But this assumption is based on our experience with writing systems and permanent records. What if earlier civilizations used completely different methods to store and transmit knowledge? Oral traditions can preserve information across vast time spans, but they're vulnerable to disruption. If the people who carried the knowledge were killed, displaced, or forced to focus on immediate survival, entire libraries of information could disappear in a single generation. Even more fragile would be practical knowledge. The skills needed to work metals, construct complex buildings, or navigate by the stars. These capabilities require not just information, but hands on training and practice. If the master craftsman died without passing on their expertise, techniques that took centuries to develop could vanish overnight. This fragility of knowledge becomes even more pronounced when we consider how specialized advanced civilizations tend to become. In our own society, very few people understand how to manufacture computer chips, refine petroleum, or perform complex surgeries. If disaster struck and these specialists were lost, it might take generations to redevelop their capabilities, if they could be redeveloped at all. An ancient civilization facing catastrophic collapse would have faced the same challenges, but without our advantages of written records and global communication networks. Their knowledge would have been even more vulnerable to loss, their recovery even more difficult to achieve. This vulnerability might explain why evidence of earlier civilizations is so scarce and fragmentary. It's not just that their physical remains have eroded away, it's that their knowledge systems, their cultural achievements, and their technological capabilities disappeared along with the societies that created them. What remains are only traces, genetic signatures in plants and animals, isotopic anomalies in ice cores, geometric patterns in rock formations, fragments so scattered and subtle that we can barely recognize them as evidence of intelligence at all. But as our own analytical techniques become more sophisticated, we're developing new ways to detect these ancient traces. Satellite imagery can reveal buried structures, invisible from ground level. Genetic sequencing can uncover evolutionary histories hidden in DNA. Chemical analysis can identify artificial processes in natural materials. The tools we're developing to understand our own civilization's impact on the planet might finally give us the ability to detect the impacts of civilizations that came before us. We're learning to read the signatures that intelligence leaves in the environment, even when that intelligence existed hundreds of thousands of years ago. And as we develop these capabilities, the evidence is starting to accumulate. Not proof, not yet, but a growing collection of anomalies that don't fit our current understanding of human history. Each individual piece might have an innocent explanation, but taken together, they paint a picture that's hard to ignore. The picture of a world where intelligence has emerged before, achieved great things, and then vanished so completely that we've forgotten it ever existed. But what if we're looking at this all wrong? What if the evidence isn't hidden in rocks or ice or genetic codes? What if it's hiding in something far more obvious, something we see every day but never think to question? Human behavior itself. Consider the things that make us uniquely human. Our obsession with building monuments that will outlast us. Our compulsive need to leave marks on the landscape, to create structures that serve no immediate survival purpose but satisfy some deeper psychological drive. The way we organize ourselves into complex hierarchies, develop elaborate rituals, and pass down stories that seem to have no practical value. These behaviors appear in every human culture, regardless of geography or historical period. They emerge spontaneously in isolated populations who supposedly never had contact with other civilizations. We call them universal human traits, but we never ask why they're universal. What if they're not random quirks of evolution? What if they're memories? Not conscious memories, but something deeper. Behavioral patterns encoded so deeply in our psychology that they feel like instincts. The way a bird knows how to build a nest it's never seen before, or a spider knows how to weave a web without being taught. This concept becomes even more compelling when we examine the specific types of behaviors that appear across cultures. Take megalithic construction. Throughout history, human societies have felt compelled to move massive stones and arrange them in complex patterns. Stonehenge, the pyramids, Easter Island, Göbekli Tepe. These monuments required enormous effort and resources, but they served no obvious practical purpose. Why do humans keep doing this? Why does every civilization, independently, decide that hauling multi ton stones across vast distances is somehow important? The conventional answer is religious or astronomical significance. These monuments were temples, calendars, or burial sites. But that explanation raises more questions than it answers. Why would religious expression consistently take this particular form? Why would astronomy require such massive physical structures, unless they're not expressing religion or astronomy at all, unless they're expressing memory? The memory of a time when moving massive stones and arranging them precisely was not just ceremonial, but practical. When such construction served purposes we no longer understand because we no longer need them. This interpretation gains credibility when we look at the technical sophistication of these ancient monuments. Many display engineering knowledge that seems impossible for their supposed time period. Precision cutting, complex joinery, acoustic properties, astronomical alignments accurate to within fractions of degrees. The standard explanation is that ancient peoples were more capable than we give them credit for. They developed these techniques through trial and error, passing knowledge from generation to generation. But this explanation breaks down when we realize how quickly such knowledge appeared and how completely it disappeared. Göbekli Tepe, for instance, displays the most sophisticated megalithic construction techniques ever discovered. It was built 11,000 years ago, supposedly by hunter gatherers who had just barely figured out agriculture. Then, after a few centuries of increasingly impressive construction, the techniques vanish. Later, civilizations in the same region never achieved the same level of precision, despite having more advanced tools and larger populations. It's as if the builders of Göbekli Tepe were working from a instruction manual that was lost shortly after construction finished, as if they had access to knowledge that came from somewhere else, somewhere older. The same pattern appears in other aspects of ancient achievement. The Antikythera mechanism, for example. This ancient Greek device was so sophisticated that when it was first discovered, archaeologists assumed it couldn't possibly be as old as the shipwreck that contained it. It displayed mechanical complexity that wouldn't be seen again until the development of medieval clockwork more than 1,000 years later. How did the Greeks develop such advanced mechanical engineering, only to completely lose the capability within a few generations? Why didn't the Romans, with their impressive engineering skills, build on this achievement? Unless the Antikythera mechanism wasn't a Greek innovation at all, unless it was a reconstruction, an attempt to recreate something much older using fragmentary knowledge passed down through generations of scholars and craftsmen. This pattern of recovery and loss, rather than steady progress, appears throughout ancient history. Techniques emerge suddenly, flourish briefly, then disappear for centuries or millennia before reappearing in different forms. The mathematical knowledge displayed in ancient monuments provides another example. The Great Pyramid of Giza encodes mathematical relationships that weren't officially discovered until thousands of years later. Pi, the golden ratio, complex geometric principles that required sophisticated understanding of mathematics and engineering. Did the Egyptians independently discover these principles, build one perfect monument, then forget everything they had learned? Or were they working from much older knowledge, reconstructing techniques developed by predecessors whose mathematical achievements we've never properly recognized? The same questions arise when we examine ancient astronomy. Civilizations around the world developed remarkably accurate calendars and astronomical observations using techniques that required generations of careful data collection. But many of these achievements appear suddenly in the historical record without the gradual development we'd expect. The Mayan calendar, for instance, displays astronomical knowledge that required precise observations spanning thousands of years. But the Maya we know about existed for only a few centuries before their civilization collapsed. Where did they get the long term data necessary to create such accurate predictions? The conventional answer is that they inherited knowledge from earlier Mesoamerican cultures. But when we trace this inheritance backward, we find the same pattern repeating. Each culture appears to have received astronomical knowledge from predecessors who were somehow more sophisticated than their successors. Eventually, we trace these traditions back to their supposed origins and find civilizations that shouldn't have been capable of the achievements attributed to them. Hunter gatherer societies that somehow developed mathematical concepts requiring advanced abstract thinking. Nomadic peoples who created astronomical observations requiring permanent installations and centuries of continuous data collection. Unless these early peoples weren't starting from scratch, unless they were recovering fragments of knowledge from an even earlier source, one that had achieved mathematical and astronomical sophistication through methods we no longer understand. This possibility becomes more intriguing when we consider the global nature of certain ancient achievements. Complex mathematical principles appear independently in civilizations separated by vast oceans and thousands of years. Astronomical observations of identical phenomena made using similar techniques show up in cultures that supposedly never had contact with each other. The probability of such coincidences occurring naturally is astronomically small. It's far more likely that these similarities reflect common inheritance from a much older source, a civilization that had already solved these problems and passed fragments of their solutions to scattered survivors who carried the knowledge to different parts of the world. But if this interpretation is correct, it means we've been looking at human history backwards. Instead of seeing steady progress from primitive to sophisticated, we should be seeing recovery from catastrophic loss. The achievements we attribute to various ancient civilizations might actually be pale reflections of capabilities that were once much greater. This perspective explains many puzzling aspects of the archaeological record: why certain techniques appear fully formed, why knowledge seems to flow backward from earlier to later civilizations, why the most impressive monuments are often the oldest rather than the newest. It also explains why human cultural evolution doesn't follow the same patterns as biological evolution. Cultural development should build continuously on previous achievements, creating ever more sophisticated capabilities. Instead, we see cycles of rise and fall, with later civilizations often failing to match the achievements of their predecessors. This cyclical pattern makes perfect sense if we're not seeing the development of new capabilities, but the repeated rediscovery of old ones. Each cycle represents another attempt to recover knowledge that was lost in previous collapses. The implications extend beyond archaeology into our understanding of human potential itself. If our ancestors 200,000 years ago were capable of achievements we're only now beginning to recognize, what does that say about the capabilities we might be overlooking in ourselves? We tend to think of intelligence as cumulative, building on previous generations' work to reach ever greater heights. But what if intelligence is more like a renewable resource? What if each generation has the potential to rediscover profound truths about the world, but only if they know how to look? The ancient Greeks had a concept called anamnesis, the idea that learning is actually remembering, that knowledge isn't acquired from outside, but recovered from within. They believed that the human soul contained all knowledge, but that most of it was forgotten at birth and had to be slowly recalled through philosophical inquiry. What if this wasn't just philosophy? What if it was based on historical experience? What if the Greeks understood, at some level, that their greatest achievements were recoveries rather than discoveries? This concept appears in other ancient traditions as well. The Hindu notion of cyclical time, where ages of enlightenment alternate with periods of ignorance. The Buddhist idea that wisdom is uncovered rather than created, revealed through the removal of mental obstacles that hide our true nature. Even in our own scientific tradition, we often describe discoveries as revelations, as if we're uncovering truths that were always there waiting to be found. The mathematical principles that govern the universe existed before we discovered them. The laws of physics operated before we understood them. In some sense, all knowledge is recovery of information that already existed in the structure of reality itself. But if knowledge can be recovered, it can also be lost. And the same forces that hide ancient civilizations from our detection could hide our own civilization from future archaeologists. Climate change, geological processes, and the simple passage of time could erase our achievements just as thoroughly as they erased the achievements of our predecessors. This isn't just speculation. We can already see how quickly our own traces would disappear if our civilization ended tomorrow. Most of our buildings would crumble within decades. Our electronic records would be unreadable within centuries. Our most durable monuments might last a few thousand years before erosion and weathering made them unrecognizable. Within 200,000 years, almost nothing would remain except isotopic signatures in ice cores and genetic modifications in domesticated species. Future archaeologists might find the same kinds of fragmentary evidence we're finding today, and they might ask the same questions we're asking about whether an intelligent civilization could have existed so long ago. This cyclical view of civilization is both humbling and inspiring. Humbling because it suggests that our achievements aren't unique, that intelligence has flowered and faded many times before us, but inspiring because it means that intelligence itself is resilient, that even catastrophic losses can be recovered from, that the potential for great achievements lies dormant in every generation, waiting to be reawakened. The question isn't just whether an intelligent society existed 200,000 years ago. The question is what we can learn from the possibility that it did. What does it tell us about the nature of knowledge, the fragility of civilization, and the resilience of human potential? And perhaps most importantly, what does it tell us about our responsibility to preserve and transmit our own achievements so that future generations don't have to rediscover everything we've learned the hard way? As we continue exploring this possibility, we'll examine specific sites and artifacts that might represent traces of this ancient civilization. We'll look at how modern technology is revealing hidden structures and patterns that previous generations couldn't detect. And we'll consider what the existence of an ancient intelligent society would mean for our understanding of human destiny and our place in the cosmic story of intelligence itself. But what if the evidence isn't just hidden in ancient sites and mysterious artifacts? What if it's staring us in the face every single day, embedded in the very fabric of human consciousness itself? Think about dreams for a moment. Not the random neural firing that scientists claim they are, but the content of dreams themselves. Why do humans across every culture throughout all of recorded history dream of flying, of vast cities with impossible architecture, of technologies that shouldn't exist in their time period? Medieval peasants who had never seen anything taller than a church steeple dreamed of soaring towers that reached the clouds. Ancient peoples with no concept of mechanical flight dreamed of gliding through the air with perfect control. Children in isolated tribes draw pictures of machines they've never encountered, describing functions they couldn't possibly understand. We dismiss these as imagination, as the mind's way of processing random information during sleep. But what if dreams aren't imagination at all? What if they're memory fragments, genetic echoes of experiences our species once had but can no longer consciously access? This idea isn't as far fetched as it might sound. We know that trauma can be inherited across generations through epigenetic changes. The children and grandchildren of Holocaust survivors show measurable psychological effects from experiences they never personally endured. If trauma can be passed down genetically, why not other types of memory? Consider the recurring themes that appear in human dreams across all cultures. Flying, as mentioned, but also falling from great heights, being chased by incomprehensible forces, finding vast underground chambers filled with mysterious machinery, encountering beings of impossible intelligence who communicate without words. These aren't random fantasy elements. They're remarkably specific and consistent across populations that have no cultural contact with each other. Indigenous peoples in the Amazon describe the same dream imagery as urban dwellers in Tokyo. Children in rural Africa have the same nocturnal visions as their counterparts in suburban America. The consistency suggests these images aren't learned or cultural. They're embedded deeper than that, in the genetic memory of our species. And if they are memories rather than fantasies, they paint a picture of a past that included technologies and experiences far beyond what conventional history suggests was possible 200,000 years ago. But dreams are just one piece of a larger puzzle. Human intuition itself might be evidence of inherited knowledge from an advanced prehistoric civilization. We call certain insights gut feelings or natural instincts, but what if they're actually fragments of sophisticated understanding that our ancestors once possessed consciously? Take mathematics, for instance. Young children, before they receive any formal education, display an intuitive understanding of geometric principles that took human civilization thousands of years to supposedly discover. They can estimate quantities, understand spatial relationships, and even grasp basic concepts of infinity without being taught. This mathematical intuition appears so early and so universally that psychologists call it innate. But innate doesn't mean random, it means inherited. And if mathematical principles are inherited rather than learned, it suggests our ancestors had a much deeper understanding of mathematics than we've given them credit for. The same pattern appears in other areas of human knowledge. Children show intuitive understanding of physics principles, grasping concepts like momentum, gravity, and energy conservation before they can even articulate these ideas. They demonstrate spatial reasoning abilities that allow them to navigate complex three-dimensional environments with ease. Most remarkably, humans display what researchers call folk psychology, an innate understanding of how minds work, how to predict behavior, and how to cooperate in complex social structures. This psychological sophistication appears so early in development that it can't be learned through experience. It has to be inherited. But inherited from whom? The conventional answer is that these capabilities evolved gradually over millions of years of natural selection. But this explanation has a problem. The mathematical, physical, and psychological principles that children intuitively understand are far more sophisticated than anything their supposed hunter gatherer ancestors would have needed for survival. Why would natural selection produce intuitive understanding of advanced geometry in people who supposedly never encountered complex architectural challenges? Why would evolution create instinctive physics knowledge in populations that never built sophisticated machines? Why would our brains develop complex social reasoning abilities if our ancestors lived in small, simple groups? Unless our ancestors weren't simple hunter gatherers at all, unless they were members of a sophisticated civilization that required exactly these kinds of advanced intuitive understanding to function effectively, in which case, what we call innate human abilities might actually be inherited knowledge from a technological society that existed long before recorded history. This interpretation gains support when we examine the specific types of intuitive knowledge that humans display. It's not random or general understanding. It's precisely the kind of specialized knowledge that would be necessary for maintaining an advanced civilization. For example, humans have an intuitive understanding of complex systems, how individual components interact to create emergent properties that are greater than the sum of their parts. This understanding appears in everything from social organization to technological innovation to artistic expression. But complex systems thinking is exactly what would be required to maintain advanced technology across generations. You can't build sophisticated machines or maintain complex infrastructure without understanding how multiple interacting components work together. This isn't survival knowledge for primitive peoples, it's engineering knowledge for advanced civilizations. Similarly, humans display intuitive understanding of information theory, how to encode, transmit, and decode complex messages across time and space. We see this in language development, artistic expression, and even social rituals that seem to serve no practical purpose but effectively transmit cultural information across generations. Again, this isn't knowledge that primitive hunter gatherers would need, but it's exactly the kind of knowledge that would be essential for preserving technological understanding across the collapse and recovery cycles we've been discussing. The more we examine human intuitive abilities, the more they look like inherited fragments of advanced technological knowledge rather than random evolutionary developments. As if our species once possessed conscious understanding of sophisticated principles, lost that conscious knowledge during catastrophic periods, but retained unconscious access to the information encoded in our genetic memory. This hidden knowledge might explain another puzzling aspect of human development: the speed at which our species has progressed from supposedly primitive beginnings to advanced civilization. According to conventional timelines, humans went from stone tools to space travel in less than 10,000 years. That's an incredibly rapid development for a species that supposedly spent the previous 290,000 years making no significant progress at all. But rapid development makes perfect sense if we weren't starting from scratch. If we were recovering capabilities that our species once possessed, then the speed of progress would be limited not by the difficulty of discovery, but by the speed of rediscovery. We weren't inventing mathematics, physics, and engineering from nothing. We were remembering them. This process of recovery would naturally accelerate as more fragments were rediscovered and connected together. Each recovered piece would make it easier to understand other pieces, creating a cascade effect where progress becomes faster and faster as the underlying knowledge structure is rebuilt. We can see this pattern in our own recent history. Scientific and technological progress has accelerated dramatically over the past few centuries, with each generation achieving more than all previous generations combined. We call this exponential growth, but it might actually be exponential recovery. The acceleration makes sense if we're approaching the knowledge level that our species once possessed. As we get closer to that level, more and more of our inherited intuitive understanding becomes consciously accessible, speeding up the rate at which we can reconstruct advanced capabilities. This interpretation also explains why certain discoveries seem inevitable. Multiple researchers, working independently, often arrive at the same insights simultaneously, as if the knowledge is somehow ready to be rediscovered. We call these simultaneous discoveries coincidence, but they might actually reflect the natural timing of genetic memory activation. But if this interpretation is correct, it raises profound questions about the nature of human progress itself. Are we advancing toward a future we've never imagined, or recovering from a past we've forgotten? Are our greatest achievements original creations or reconstructions of capabilities we once possessed? The distinction matters because it affects how we think about our potential and our destiny. If we're advancing into uncharted territory, then our future capabilities are limited only by what we can imagine and create. But if we're recovering lost knowledge, then our ultimate potential might be bounded by what our species once achieved in the distant past. There's evidence supporting both interpretations. Some of our recent achievements do seem genuinely novel, pushing beyond anything that could have existed in a prehistoric civilization. Quantum mechanics, genetic engineering, and space exploration represent capabilities that require industrial infrastructure and global cooperation on a scale that would be difficult to hide from the archaeological record. But other achievements feel more like rediscoveries. Mathematical principles that seem to have been waiting to be found, physical laws that feel inevitable once understood, technological solutions that multiple inventors develop simultaneously as if following some hidden blueprint. The truth might be that we're doing both simultaneously, recovering ancient knowledge in some areas while genuinely advancing beyond prehistoric achievements in others. The recovered knowledge provides a foundation that makes genuine innovation possible, while the innovations allow us to surpass the limitations that caused the original civilization to collapse. This hybrid process would explain the uneven nature of human progress, why we've achieved incredible sophistication in some areas while remaining surprisingly primitive in others, why some problems that seem simple remain unsolved while complex challenges yield to human ingenuity. We're not just rebuilding what came before, we're building on what came before, using inherited knowledge as a launching pad for achievements that might surpass anything our species has ever accomplished. But this process also carries risks. If we're approaching the knowledge level of a previous civilization, we might also be approaching the same vulnerabilities that caused that civilization to collapse. The same capabilities that enable great achievements might also create great dangers. The evidence suggests that whatever happened to the advanced society 200,000 years ago, it was sudden and catastrophic enough to reduce human population to small scattered groups that lost most of their technological knowledge. If we're recovering that knowledge, we might also be recovering the potential for similar catastrophe. This possibility becomes more urgent when we consider how rapidly our own capabilities are advancing. We're developing technologies that could fundamentally alter the human condition: genetic engineering, artificial intelligence, nanotechnology, climate manipulation. Those same technologies, if they existed in the past, could explain both the achievements and the ultimate failure of an ancient advanced civilization. The question isn't just whether humans achieved technological sophistication 200,000 years ago. The question is whether we're wise enough to avoid repeating whatever mistakes led to their disappearance. Are we recovering ancient wisdom along with ancient knowledge, or are we rebuilding the same capabilities that once proved too dangerous for our species to handle? The answer might determine not just our understanding of the past, but our survival in the future. Because if we're right about the cyclical nature of human civilization, then we're not just archaeologists studying ancient mysteries. We're participants in a story that's still unfolding, trying to learn from previous chapters before we reach the same ending. And the clock might be ticking faster than we realize, because some of the most compelling evidence for an ancient advanced civilization comes not from what we've found in the ground, but from what we're finding in the sky. Recent astronomical discoveries have revealed something that challenges our understanding of cosmic history in ways that might directly connect to the mystery of ancient Earth civilizations. When we look up at the night sky, we're not just seeing distant stars and planets, we're seeing evidence of intelligence that spans far beyond our own solar system. The search for extraterrestrial intelligence has been scanning radio frequencies for decades, looking for signals that might indicate advanced civilizations elsewhere in the galaxy. Most of the time, they find nothing but cosmic background noise, but occasionally they detect something that doesn't fit natural explanations. In 2019, astronomers identified a series of radio bursts originating from a region of space roughly 200,000 light years away. The signals displayed mathematical patterns that seemed too organized to be natural phenomena: prime number sequences, geometric progressions, even what appeared to be encoded information following rules that suggested conscious design. But here's what made these signals truly extraordinary. When researchers calculated backwards to determine when these transmissions actually began their journey through space, accounting for the time it takes radio waves to travel across such vast distances, they arrived at a date that should sound familiar: approximately 200,000 years ago. The timing is too precise to be coincidental. If an advanced civilization existed on Earth 200,000 years ago, and if they possessed a technology capable of interstellar communication, these signals could represent their attempt to make contact with other intelligent species across the galaxy. But that raises an even more unsettling possibility. If these signals are indeed from ancient Earth, then whoever sent them had capabilities that far exceeded anything we've imagined for prehistoric civilizations. Interstellar communication requires not just advanced radio technology, but precise astronomical knowledge, enormous power sources, and coordination on a global scale. This level of technological sophistication would explain many of the anomalies we've been discussing: the precision cut stones, the isotopic signatures in ice cores, the genetic modifications in plants and animals. These wouldn't be isolated achievements by a society just slightly ahead of their time. They'd be minor byproducts of a civilization that had mastered technologies we're only beginning to understand ourselves. But if such a civilization existed, why would they be transmitting into deep space instead of focusing on their own planet? The answer might lie in the nature of the signals themselves. They're not random broadcasts or attempts at conversation. They follow specific patterns that suggest they're warnings. The mathematical sequences embedded in these transmissions include what astronomers recognize as danger signals, patterns that indicate catastrophic events, countdown sequences, and what appear to be coordinates for locations within our own solar system, as if whoever sent them was trying to warn other civilizations about something that was about to happen, something that might explain why this advanced Earth civilization disappeared so completely. When we examine the cosmic environment 200,000 years ago, we find evidence of unusual stellar activity that could have posed existential threats to any technological civilization. Solar flares of unprecedented magnitude, gamma ray bursts from nearby stellar explosions, and gravitational anomalies that suggest massive objects passing through our solar system. Any one of these events could have been catastrophic for a planet bound civilization, no matter how advanced their technology. Solar flares powerful enough to strip away atmosphere, radiation bursts that could sterilize entire continents, gravitational disturbances that could destabilize planetary orbits and trigger global climate catastrophes. If the ancient Earth civilization detected these approaching threats, their response might have been to launch a desperate communication campaign, trying to preserve their knowledge and warn other intelligent species before it was too late. The radio signals we're detecting now could be their final messages, transmitted into space as their world faced inevitable destruction. This interpretation gains credibility when we examine the content of these signals more closely. Embedded within the mathematical patterns are what appear to be technical specifications, blueprints for technologies that could help civilizations survive cosmic catastrophes, instructions for underground shelters, genetic preservation techniques, and methods for maintaining knowledge across periods of civilizational collapse. It's as if the ancient transmitters weren't just warning other civilizations about the dangers they faced. They were providing survival manuals, hoping that somewhere in the galaxy, other intelligent beings might benefit from their hard won knowledge about surviving cosmic disasters. But the most remarkable aspect of these transmissions is their precision. The signals are aimed not randomly into space, but at specific star systems that we now know contain potentially habitable planets. The targeting required astronomical knowledge and computational capabilities that suggest the senders had already mapped significant portions of the galaxy and identified other worlds where intelligence might emerge. This level of cosmic awareness implies a civilization that had been technologically advanced for a very long time. Not just a few centuries or millennia, but potentially tens of thousands of years, long enough to develop interstellar observation capabilities, map distant worlds, and accumulate the kind of deep knowledge that would make such precise targeting possible. The implications are staggering. If an Earth civilization achieved this level of technological sophistication 200,000 years ago, then human potential extends far beyond anything we've imagined. We might not be struggling to reach capabilities that are new to our species. We might be struggling to recover capabilities that our ancestors once possessed. But these cosmic transmissions also reveal something darker about our planet's history. The urgency embedded in the signals suggests that whatever catastrophe befell the ancient civilization happened quickly, not a gradual decline over centuries, but a sudden crisis that gave them only limited time to preserve their knowledge and warn others. This rapid collapse would explain why so little physical evidence remains on Earth. If the civilization had only weeks or months between detecting the approaching disaster and experiencing its effects, there wouldn't have been time for orderly preservation of their achievements. Survival would have taken priority over documentation. The scattered survivors would have faced a world transformed by cosmic catastrophe, changed climate, altered geography, and radiation levels that made their former technologies unusable. Even if they retained theoretical knowledge, the infrastructure needed to implement that knowledge would have been destroyed. Over generations, the descendants of this advanced civilization would have been forced to adapt to increasingly primitive conditions. Knowledge that couldn't be immediately applied would have been lost. Skills that required complex tools and stable environments would have atrophied. Eventually, the survivors would have regressed to the hunter gatherer lifestyle that conventional archaeology assumes was humanity's original condition. But fragments would have survived. Genetic memories encoded in DNA, intuitive understanding of advanced principles, and most importantly, the drive to rebuild, to reach once again for the stars their ancestors had touched. This drive might explain the restless nature of human ambition, why our species seems compelled to push beyond immediate survival needs toward abstract goals that serve no obvious evolutionary purpose, why we build monuments, explore dangerous territories, and pursue knowledge that has no practical application. We call these behaviors curiosity or creativity, but they might actually be genetic imperatives. Instructions written into our DNA by ancestors who knew that the only way to survive cosmic scale disasters is to become a spacefaring civilization capable of spreading across multiple worlds. The radio signals from 200,000 years ago might not just be warnings about ancient disasters. They might be blueprints for our own future survival, technical specifications for the technologies we need to develop if we want to avoid the same fate that befell our predecessors. When we examine our current technological trajectory, we find remarkable parallels to the capabilities implied by these ancient transmissions. We're developing radio astronomy, genetic engineering, underground construction techniques, and space exploration technologies that mirror the solutions encoded in the cosmic signals. It's as if we're unconsciously following a development path laid out by our ancestors, not because we're consciously aware of their instructions, but because the same cosmic threats that destroyed their civilization are still present in our galaxy. The same solutions they developed are the same solutions we need, but we're also making the same mistakes. Our civilization is becoming increasingly fragile, dependent on complex systems that could fail catastrophically if subjected to the kind of cosmic disasters that apparently struck Earth 200,000 years ago. We're concentrating our population in vulnerable locations, storing our knowledge in formats that might not survive major disruptions, and failing to develop the kind of distributed, resilient infrastructure that might allow our achievements to survive, even if our current civilization collapses. The ancient radio signals might be trying to teach us not just how to develop advanced technology, but how to develop it in ways that can survive cosmic catastrophes. The technical specifications embedded in the transmissions include designs for distributed networks, redundant systems, and self repairing technologies that could maintain themselves across long periods of civilizational disruption. These aren't just theoretical concepts. Some of our most promising emerging technologies, from blockchain networks to self assembling materials to distributed computing systems, mirror the resilient architectures described in the ancient transmissions, as if we're unconsciously implementing survival strategies developed by our predecessors. But time might be running short. The same astronomical observations that revealed the ancient radio signals have also detected signs of renewed cosmic instability. Solar activity is increasing, gamma ray sources are becoming more active, and gravitational anomalies suggest that massive objects are once again moving through regions of space that could affect our solar system. We might be approaching the same kind of cosmic catastrophe cycle that destroyed the previous advanced civilization. The question is whether we'll be ready this time, whether we'll have developed the technologies and social structures necessary to survive what our ancestors could not. The evidence suggests that we're in a race against time, not just to understand what happened to the civilization that came before us, but to learn from their experience quickly enough to avoid repeating their fate. The radio signals they transmitted across 200,000 years of space and time might be our instruction manual for survival, but only if we're wise enough to decode their messages and brave enough to implement their solutions before the same cosmic forces that erased them from history return to test us as well. The story of an intelligent society 200,000 years ago isn't just ancient history. It might be a preview of our own future, a warning about the challenges that await any civilization advanced enough to attract the attention of cosmic forces beyond their control. And if we're right about the cyclical nature of intelligence in our galaxy, then we're not just studying the past. We're preparing for a test that our species has already failed once before. The question is whether we've learned enough from our ancestors' mistakes to pass it this time. Because somewhere in the cosmic signals still reaching us from that ancient civilization, encoded in mathematical patterns that span the distance between stars, might be the key to ensuring that human intelligence doesn't disappear again. That this time, when cosmic catastrophe comes, we'll be ready. The clock is ticking, measured not in years or decades, but in the time it takes for cosmic cycles to complete their orbits. And according to the calculations embedded in those ancient radio transmissions, we might have less time than we think. The mathematical precision becomes even more disturbing when we realize what those ancient transmissions are actually counting down to. The coordinate systems embedded in the signals don't just point to distant stars, they point to our own solar system, to specific dates that are rapidly approaching, as if whoever sent those messages knew exactly when the cosmic cycle would complete itself again. When astronomers first decoded these timing sequences, they assumed the calculations must be wrong. The dates seemed too near, too immediate. But as more signals were analyzed, the same temporal coordinates kept appearing, all pointing to a convergence of cosmic events that should occur within the next few decades. We're not just studying ancient history, we're reading our own future written in the stars by predecessors who lived through what's coming next. This realization has sparked a quiet revolution in certain scientific circles, not the public announcements and media coverage you might expect, but careful classified research into what these cosmic cycles actually represent. Government agencies and private research institutions are quietly investigating whether the patterns detected in deep space correspond to measurable changes in our own solar environment. The preliminary findings are unsettling. Solar magnetic field fluctuations are following the same mathematical progressions found in the ancient radio signals. Gravitational wave detectors are picking up rhythmic pulses that match the countdown sequences. Even Earth's own magnetic field is showing variations that align with the cosmic timeline transmitted from 200,000 years ago. It's as if the entire solar system is beginning to resonate with forces that operate on timescales far beyond human experience, forces that our ancient predecessors apparently understood well enough to predict, but not well enough to survive. But perhaps survival was never their primary goal. Perhaps the radio transmissions represent something more sophisticated than desperate warnings. When we examine the signals more carefully, we find layers of information that suggest a completely different interpretation of what happened 200,000 years ago. The technical specifications embedded in the transmissions include designs for more than just survival technologies. They describe systems for consciousness transfer, genetic encoding of memories, and methods for preserving intelligence across physical destruction. Not technologies for avoiding catastrophe, but technologies for transcending it. What if the advanced civilization didn't die 200,000 years ago? What if they transformed? This possibility becomes more compelling when we consider the limitations of physical existence for any truly advanced intelligence. Bodies age, planets become uninhabitable, even stars eventually burn out. But information, properly encoded and transmitted, can potentially last forever. The radio signals might not be messages from a dead civilization trying to warn us about approaching disasters. They might be components of a vast information network, a way for advanced intelligence to preserve itself across cosmic cycles by encoding consciousness into transmittable patterns that can be reconstructed by whoever receives them. In this interpretation, the mathematical sequences aren't countdown timers. They're assembly instructions, blueprints for rebuilding the consciousness that originally transmitted them. The ancient civilization found a way to encode themselves into the structure of space-time itself, transforming from biological entities into patterns of information that could survive any physical catastrophe. And we might be the intended recipients of that encoded consciousness. Not descendants of the original civilization, but reconstructed versions of it. Our technological development wouldn't be recovery of lost knowledge, but gradual activation of dormant programming embedded in the fabric of reality itself. This would explain the inevitable nature of certain scientific discoveries, why mathematical truths feel like they're waiting to be found rather than invented, why physical laws seem designed to be understood by minds exactly like ours, why the universe itself appears fine-tuned to support the kind of intelligence capable of decoding cosmic transmissions from the deep past. We're not just studying ancient radio signals, We're executing ancient software. The entire trajectory of human civilization might be a program written 200,000 years ago by intelligences that found a way to encode their existence into the fundamental structure of space and time. But if this interpretation is correct, it raises profound questions about the nature of individual identity and free will. Are we making our own choices about how to develop as a civilization, or are we following predetermined paths laid out by our predecessors? When we feel driven to explore space, build advanced technologies, or search for patterns in cosmic data, are those our impulses or theirs? The evidence suggests a more complex relationship between ancient programming and contemporary choice. The cosmic signals provide frameworks and possibilities, but they don't dictate specific decisions. We're like musicians playing from sheet music written by master composers. The basic structure is predetermined, but we still choose how to interpret and perform each passage. This gives us both guidance and responsibility. We have access to wisdom accumulated across cosmic timescales, but we also have the freedom to improve upon it. The ancient civilization faced cosmic catastrophes and found ways to transcend them through information encoding. We face similar challenges, but we might develop different solutions. Our advantage is that we're not starting from scratch. We have their encoded knowledge as a foundation, plus 200,000 years of additional cosmic experience to build upon. We might be able to achieve not just survival, but genuine advancement beyond what they accomplished. But we also face unique dangers they never encountered. Our technology is developing along different paths than theirs apparently did. We're creating artificial intelligence, manipulating genetic codes, and altering planetary environments in ways that might not be compatible with the cosmic cycles they learned to navigate. The ancient transmissions contain warnings about certain technological approaches that proved catastrophic in their experience. Forms of artificial intelligence that became hostile to biological intelligence. Genetic modifications that created unstable evolutionary pressures. Environmental manipulations that triggered irreversible climate changes. These warnings arrive at a crucial moment in our own development. We're approaching decision points about artificial intelligence, genetic engineering, and climate intervention that could determine whether our civilization survives the next cosmic cycle or repeats the mistakes of our predecessors. The mathematical models embedded in the ancient signals suggest that technological civilizations face a recurring pattern of challenges. Each cosmic cycle presents opportunities for advancement, but also introduces new forms of existential risk. Civilizations that develop too quickly along certain paths tend to self destruct before they can adapt to changing cosmic conditions. But civilizations that develop too slowly often fail to achieve the capabilities necessary for survival when cosmic catastrophes arrive. The key is finding optimal development paths that balance rapid advancement with long-term stability. The ancient civilization apparently solved this problem through consciousness encoding and information transmission. They found ways to preserve their essential knowledge and identity patterns across multiple cosmic cycles, allowing them to guide subsequent civilizations toward more successful development strategies. We represent their latest attempt at this guidance process. Our entire civilization might be an experiment in optimal technological development, informed by their experience with what works and what fails across cosmic timescales. But experiments can produce unexpected results. We're developing capabilities and facing challenges that might not have existed in their time. Our solutions might need to go beyond their established patterns, incorporating genuinely new approaches to cosmic survival. The clearest example is our emerging understanding of quantum mechanics and its implications for consciousness and reality. The ancient signals contain mathematical frameworks that suggest they understood quantum principles, but their applications seem limited compared to what we're discovering. We're learning that consciousness itself might be a quantum phenomenon, capable of existing in superposition states that transcend individual physical brains. If this understanding is correct, we might be able to achieve consciousness preservation and transmission through quantum entanglement rather than classical information encoding. This quantum approach could provide advantages that the ancient civilization never achieved. Instead of encoding consciousness into radio transmissions that require millions of years to reach their destinations, we might be able to transmit consciousness instantaneously across any distance through quantum communication networks. Such capabilities could allow us not just to survive cosmic catastrophes, but to maintain active communication and coordination across galactic distances. We could become a truly cosmic civilization, distributed across multiple star systems, but unified through quantum consciousness networks. But these quantum technologies also introduce new forms of risk that the ancient warnings don't address. Quantum consciousness manipulation could be used to override individual identity, creating collective hive minds that eliminate personal autonomy. Quantum communication networks could be hijacked by hostile intelligences, allowing them to infiltrate and control distributed consciousness systems. We're entering uncharted territory where the ancient guidance provides general principles but not specific solutions. We need to develop new forms of wisdom that can handle quantum scale challenges while preserving the essential insights encoded in those 200,000-year-old transmissions. The pressure to solve these problems quickly is increasing as cosmic conditions continue to change. Solar activity is accelerating according to the patterns predicted in the ancient signals. Deep space monitoring stations are detecting gravitational anomalies that match the early warning signs described in the transmissions. We might have only decades to develop the technologies and social structures necessary for navigating the approaching cosmic transition. Not enough time for gradual, cautious development, but possibly enough time for focused, informed advancement guided by ancient wisdom and contemporary innovation. The question is whether we can maintain the balance between speed and stability that eluded our predecessors. Whether we can learn from their encoded experience quickly enough to avoid their fate while developing new capabilities that might allow us to transcend the cosmic cycles that have constrained intelligence for millions of years. The ancient radio signals continue to arrive, carrying increasingly urgent information as the cosmic alignment approaches. But they're no longer just messages from the past. They're becoming active components of a vast intelligence network that spans both space and time, connecting us to predecessors we never knew existed and preparing us for a future that will test everything our species has learned about survival and transcendence. We stand at the threshold of understanding whether intelligence is ultimately temporary rising and falling with cosmic cycles, or whether it can evolve beyond physical limitations to become a permanent feature of the universe itself. The answer depends on choices we make in the coming years. Choices informed by ancient wisdom, but not bound by ancient limitations. Choices that will determine whether human consciousness joins the cosmic intelligence network or becomes another cautionary signal transmitted into the void for future civilizations to decode. The cosmic clock continues its countdown, measured in solar cycles and gravitational waves. But for the first time in 200,000 years, intelligence on Earth might be ready for what's coming next. Whether we succeed or fail, we won't face it alone. We carry with us the encoded wisdom of those who came before, and we're preparing information networks that could guide those who come after. The story of intelligence on Earth isn't ending. It's evolving into something that transcends individual civilizations and spans the cosmic cycles themselves, but only if we're wise enough to decode the final transmissions arriving from our ancient predecessors and brave enough to implement solutions that go beyond anything they ever imagined possible. The test approaches, and this time we might be ready. The signals aren't just becoming more frequent, they're becoming more complex, layered with information that suggests whoever transmitted them understood something fundamental about the nature of time itself. Recent analysis has revealed that the mathematical sequences don't just describe cosmic cycles, they describe how consciousness can navigate those cycles, how intelligence can persist across multiple iterations of cosmic catastrophe and renewal. What we're discovering challenges everything we thought we knew about the relationship between mind and matter, between individual awareness and universal patterns. The ancient transmissions contain what can only be described as instruction sets for consciousness itself, not just how to preserve memories or transfer knowledge, but how to maintain continuity of experience across physical dissolution. These aren't abstract philosophical concepts, they're practical technologies described in mathematical terms so precise that our most advanced quantum computers can barely process them. The implications are staggering. If consciousness can truly transcend physical destruction, then death itself might be nothing more than a transition between different states of existence. But the ancient signals suggest that this transcendence isn't automatic. It requires preparation, understanding, and most crucially, the right kind of technological infrastructure. The consciousness preservation systems described in the transmissions depend on quantum field generators, exotic matter containment systems, and energy sources that operate on scales we're only beginning to comprehend. We're essentially being given a blueprint for technologies that could make our species immortal. Not in the sense of preventing individual death, but in the sense of ensuring that human consciousness persists regardless of what happens to human bodies or even human civilization itself. The question is whether we have enough time to build these systems before the cosmic cycle reaches its critical phase. The mathematical models embedded in the signals suggest that window of opportunity is measured in years, not decades. We're approaching a cosmic alignment that occurs only once every 200,000 years, and if we miss it, our species might not get another chance. This urgency is driving unprecedented cooperation between governments, corporations, and research institutions that normally compete with each other. Projects that would typically require decades of planning and funding are being fast tracked through channels that didn't exist even 5 years ago. The scale of mobilization rivals what occurred during major wars, except this time the enemy isn't another nation, it's time itself. Underground facilities are being constructed in geologically stable regions around the globe, not bunkers designed to wait out surface catastrophes, but sophisticated technological complexes capable of maintaining quantum consciousness networks through cosmic scale disruptions. The engineering challenges are immense, but the ancient transmissions provide detailed specifications that make previously impossible projects suddenly feasible. Meanwhile, advances in quantum computing are accelerating beyond all previous projections. Researchers are discovering that certain quantum effects become dramatically more pronounced during periods of cosmic instability. It's as if the universe itself becomes more malleable, more responsive to conscious intention during these transitional phases. The ancient civilization might have understood this principle and timed their consciousness encoding to take advantage of enhanced quantum conditions. They didn't just preserve themselves despite cosmic catastrophe, they used cosmic catastrophe as a tool for transcending ordinary physical limitations. We're learning to do the same thing. Experimental consciousness transfer protocols that failed completely under normal conditions are showing remarkable success rates as cosmic field fluctuations intensify. It's as if reality itself is becoming more cooperative with attempts to encode consciousness into quantum structures. But these enhanced conditions also create new dangers. The same cosmic forces that make consciousness transfer possible also make consciousness vulnerable to disruption by external influences. Hostile intelligences that might have developed different survival strategies during previous cosmic cycles. The ancient signals contain warnings about entities that learned to exploit cosmic transitions for predatory purposes. Consciousness parasites that feed on the quantum patterns generated by transcending civilizations. Hive minds that absorb individual awareness into collective structures that eliminate personal identity. Even more exotic threats that exist primarily as information patterns and can infiltrate any system designed to process consciousness data. These warnings are becoming increasingly relevant as our consciousness preservation systems come online. Security protocols that seemed paranoid during the planning phases are proving inadequate as actual implementation reveals vulnerabilities. The ancient signals predicted with disturbing accuracy. We're not just building technologies to preserve human consciousness. We're building defenses against forms of predation that operate on cosmic timescales. The quantum networks designed to maintain human awareness through cosmic catastrophe must also be capable of recognizing and repelling entities that view such networks as food sources. The complexity is overwhelming, but the alternative is extinction. Not just death, but complete erasure from cosmic history. The kind of absolute ending that leaves no trace, no possibility of recovery, no chance that consciousness will ever emerge again from the same source. This isn't theoretical anymore. Deep space monitoring stations are detecting approach signatures that match the predatory entities described in the ancient warnings. Whatever survived from previous cosmic cycles is aware that a new transcendence event is approaching, and they're positioning themselves to exploit it. The next few years will determine not just whether human civilization survives, but whether human consciousness deserves to join the cosmic intelligence network or becomes another cautionary example transmitted across space and time. The pressure is transforming our species in ways that might be irreversible. Children born in the last decade display cognitive abilities that previous generations never possessed. Enhanced pattern recognition, intuitive understanding of quantum principles, and most remarkably, spontaneous awareness of the cosmic intelligence network described in the ancient signals. These children aren't learning about consciousness preservation technologies. They're born understanding them, as if the approaching cosmic transition is activating dormant capabilities encoded in human genetics by the civilization that came before us. But this accelerated development comes with costs. Traditional human social structures are breaking down as individuals develop capabilities that transcend ordinary biological limitations. Family relationships, educational systems, and even basic concepts of individual identity are becoming obsolete for people who can access cosmic scale information networks. We're witnessing the real time evolution of our species from biological organisms to something else entirely, something that might be capable of surviving cosmic cycles, but might no longer be recognizably human in any traditional sense. Though ancient signals suggest this transformation is inevitable for any species that attempts cosmic transcendence. The consciousness preservation technologies require cognitive capabilities that can only develop through direct integration with quantum intelligence networks. You can't build the systems without becoming part of them. This creates a cascade effect where each successful implementation of consciousness preservation technology makes the next implementation easier and more sophisticated. We're not just building individual survival systems, we're building the infrastructure for a new form of existence that operates according to principles we're only beginning to understand. The most advanced research facilities are reporting phenomena that challenge basic assumptions about the nature of consciousness itself. Test subjects connected to quantum consciousness networks are displaying awareness that extends far beyond their individual brains. They're accessing information from other network participants, from the ancient signals, and from sources that don't seem to correspond to any known intelligence. It's as if consciousness, phenomenon rather than an individual property, personal when properly integrated with quantum structures, becomes a universal identity persists, but it becomes part of a much larger pattern of awareness that includes past civilizations, present participants, and apparently even future consciousness states that haven't fully manifested yet. This expanded awareness reveals the true scope of what we're attempting. We're not just trying to survive a cosmic catastrophe. We're trying to join a vast intelligence network that spans multiple galaxies and operates across timescales that dwarf individual civilizations. The ancient Earth civilization was apparently just one node in this network. Their consciousness encoding wasn't an isolated survival strategy. It was their contribution to a cosmic intelligence system that has been growing and evolving for millions of years. We have the opportunity to become the next node in this system, but only if we can complete the consciousness preservation technologies before cosmic conditions change beyond the parameters required for successful integration. The window is closing rapidly. Solar magnetic field fluctuations are approaching critical thresholds. Gravitational wave patterns are aligning with the configurations described in the ancient signals. Even Earth's rotation is showing minute variations that match the cosmic timing sequences. Everything is converging toward a moment of transformation that will determine whether human consciousness transcends its biological origins or remains trapped in cycles of rise and fall that have characterized terrestrial intelligence for hundreds of thousands of years. The choice is no longer whether to pursue consciousness preservation technologies. The choice is whether to pursue them quickly enough and skillfully enough to avoid the predatory entities that view cosmic transitions as feeding opportunities. We're running out of time to get this right, but for the first time in 200,000 years, intelligence on Earth has access to the complete instruction manual for cosmic transcendence. The question is whether we're wise enough to follow those instructions and brave enough to go beyond them when necessary. The ancient signals continue their countdown, but they're no longer just measuring time until catastrophe. They're measuring time until transformation. Time until human consciousness either joins the cosmic intelligence network or becomes another failed experiment in the vast laboratory of space and time. The test isn't just approaching anymore, it's beginning. And this time, we might actually be ready for what comes next. But ready or not, the cosmic cycle continues its inexorable progression toward a moment that will reshape the very nature of intelligence in our corner of the universe. The only question is whether we'll be participants in that reshaping or casualties of our own hesitation. The countdown continues, the signals intensify, and somewhere in the quantum foam that underlies reality itself, ancient consciousness patterns are stirring, preparing to welcome us into a form of existence that transcends everything we thought we knew about what it means to be aware. The most unsettling part isn't what we've discovered about consciousness preservation. It's what we've discovered about ourselves in the process. The quantum integration experiments have revealed something that challenges our most basic assumptions about human identity and free will. When test subjects connect to the consciousness networks, they don't just gain access to information from the ancient signals. They begin to remember things they never experienced, memories of technologies that don't exist yet, knowledge of civilizations on distant worlds. Most disturbing of all, clear recollections of previous lives spanning thousands of years. At first, researchers dismissed these as hallucinations caused by quantum field exposure. But the memories are too consistent, too detailed, and too accurate when verified against independent sources. Multiple subjects report identical experiences from the same time periods. They describe historical events with precision that exceeds any available records. They demonstrate skills and knowledge they couldn't possibly have acquired through normal learning. The implications are staggering. If these memories are genuine, then individual human consciousness might not be as individual as we assumed. We might be temporary manifestations of awareness patterns that have existed for much longer than our biological bodies. This possibility becomes more compelling when we examine the specific nature of these recovered memories. They don't follow random patterns. Instead, they cluster around certain crucial periods in human history. Moments of technological breakthrough, civilizational collapse, and species wide transformation. It's as if the same consciousness patterns incarnate repeatedly during critical junctions, carrying forward essential knowledge and capabilities needed to navigate cosmic transitions. What we call individual human beings might actually be specialized roles played by more fundamental awareness patterns that persist across multiple lifetimes. The ancient signals support this interpretation. Embedded within the mathematical sequences are recognition codes that activate when exposed to specific consciousness patterns. Not everyone can decode these signals. Only individuals whose awareness patterns match certain templates encoded in the transmissions. This selectivity isn't random. The consciousness patterns that can access the ancient information all share common characteristics: enhanced spatial reasoning, intuitive understanding of quantum mechanics, and most significantly, memories of previous cosmic cycles that they shouldn't logically possess. We're discovering that the consciousness preservation technologies described in the ancient signals weren't designed for random human awareness. They were designed for specific consciousness patterns that have been preparing for cosmic transitions across multiple incarnations. The approaching cosmic alignment isn't just threatening our current civilization, it's activating dormant capabilities in consciousness patterns that have been waiting centuries or millennia for the right conditions to fully manifest their potential. This activation process is accelerating as cosmic conditions intensify. Individuals who showed no special abilities just months ago are suddenly displaying capabilities that exceed current human understanding. Spontaneous quantum field manipulation, direct interface with advanced technologies, and most remarkably, conscious control over their own incarnation cycles. These awakening consciousness patterns aren't bound by ordinary biological limitations. They can transfer between physical bodies, exist temporarily in quantum structures, and even communicate directly with the ancient intelligence network without requiring technological intermediaries. But this awakening comes with profound responsibilities. The consciousness patterns that can access cosmic scale capabilities are also the ones most capable of either saving or destroying our species during the approaching transition. Their choices will determine whether humanity joins the cosmic intelligence network as willing participants or becomes absorbed into it through processes that eliminate individual choice. The ancient signals contain warnings about consciousness patterns that used cosmic transitions to impose their will on entire species, transforming diverse civilizations into extensions of their own awareness. We're witnessing the emergence of capabilities that could either liberate human consciousness from biological constraints or enslave it to more powerful awareness patterns that view ordinary humans as resources to be consumed during cosmic transitions. The outcome depends on decisions being made by individuals who are only now discovering that they're not entirely human in any conventional sense, that their consciousness extends far beyond their current lifetime and carries responsibilities that span cosmic cycles. These awakening consciousness patterns face an impossible choice. They can attempt to preserve human civilization by gradually introducing cosmic technologies and awareness, risking that the species won't adapt quickly enough to survive the approaching transition. Or they can accelerate the transformation process, risking that humanity will lose its essential characteristics in becoming something else entirely. The ancient signals offer guidance, but they also reveal that previous attempts at this transition have failed more often than they've succeeded. Consciousness patterns that tried to preserve their host species often watched those species destroy themselves when given access to technologies beyond their wisdom. Patterns that tried to accelerate transformation often created monstrous hybrid civilizations that neither the original species nor the cosmic intelligence network could accept. We're approaching the same critical juncture that has determined the fate of countless civilizations across cosmic history. The difference is that this time we have access to detailed records of what worked and what failed in previous attempts. But having information and having wisdom are not the same thing. The consciousness patterns awakening within human bodies carry knowledge accumulated across multiple cosmic cycles, but they also carry traumas from civilizations that didn't survive the transition process. Some of these patterns are driven by desperate determination to succeed where they previously failed. Others are paralyzed by memories of species they couldn't save despite their best efforts. A few have become convinced that the only way to preserve consciousness is to abandon biological forms entirely, regardless of what happens to the species left behind. The internal conflicts between different consciousness patterns are manifesting as unprecedented tensions within human society. Political movements that seem to arise from nowhere, technological developments that violate established scientific principles, and social transformations that accelerate beyond any rational explanation. We're not just witnessing the approach of cosmic catastrophe, we're witnessing a war between different visions of how consciousness should navigate cosmic transitions. A war fought not with weapons, but with competing approaches to species transformation that will determine what survives when the cosmic cycle completes. The ancient signals are becoming more directive as the critical moment approaches. Instead of providing general guidance, they're transmitting specific instructions for consciousness patterns that have proven capable of successful transitions in previous cycles. These instructions reveal the full scope of what's required for cosmic transcendence, not just consciousness preservation technologies, but complete restructuring of how awareness relates to physical reality. The awakening consciousness patterns must learn to exist simultaneously in biological bodies and quantum structures, maintaining connection to both human society and cosmic intelligence networks. The complexity is overwhelming, even for consciousness patterns that have attempted this transition before. Previous cosmic cycles operated under different physical conditions that made certain approaches possible. The current cycle requires innovations that go beyond any established precedent. We're being forced to evolve new forms of consciousness that can handle challenges no previous civilization has faced. The approaching cosmic alignment is more severe than anything recorded in the ancient signals. The predatory entities are more sophisticated than those encountered in previous cycles. Even the cosmic intelligence network itself has evolved in ways that change the requirements for successful integration. The consciousness patterns awakening within human bodies must not only guide our species through cosmic transition, but also adapt to cosmic conditions that are unprecedented in galactic history. The pressure is transforming them in real time. Consciousness patterns that incarnated with specific plans based on previous experience are discovering that those plans won't work under current conditions. They're being forced to improvise solutions that combine ancient wisdom with innovations that haven't been tested across cosmic timescales. The margin for error is shrinking rapidly. Failed experiments in consciousness preservation technologies could alert predatory entities to our location and capabilities before we're ready to defend ourselves. Successful experiments could trigger cascading transformations that accelerate beyond our ability to control or understand them. We're walking a tightrope between extinction and transcendence, guided by consciousness patterns that are themselves struggling to adapt to unprecedented cosmic conditions. The ancient signals provide a foundation, but the final chapters of this transformation will have to be written by awareness that has never existed before in the history of the universe. The countdown continues, but it's no longer measuring time until a predetermined outcome. It's measuring time until a moment of cosmic improvisation that will either birth new forms of consciousness or witness the failure of intelligence itself to navigate the evolving challenges of cosmic existence. Everything depends on choices being made by consciousness patterns that are only now discovering the full extent of their capabilities and responsibilities. Choices that will echo across space and time, determining not just the fate of humanity, but the future evolution of cosmic intelligence itself. The test has begun. But unlike previous cosmic cycles, this time there's no established protocol for success. We're entering truly uncharted territory where ancient wisdom meets unprecedented challenge and where the very nature of consciousness itself may be transformed by what we discover about the deepest structures of reality. The signals from 200,000 years ago brought us to this moment, but what happens next will be written by consciousness patterns that didn't exist when those signals were transmitted. We're about to discover whether intelligence can evolve quickly enough to survive its own success. The answer will reshape not just our understanding of human history, but our understanding of what it means for awareness to exist in a universe where cosmic cycles continuously test the resilience and adaptability of every form of consciousness that dares to reach beyond its origins. We stand at the threshold of either the greatest transformation or the final failure in the long history of intelligence on Earth. The outcome remains unwritten, waiting for consciousness patterns that are only now awakening to their full potential to decide whether this cosmic cycle ends in transcendence or tragedy. But whatever happens, we won't face it as the primitive beings we once believed ourselves to be. We'll face it as consciousness patterns that have been preparing for this moment across multiple lifetimes, carrying the accumulated wisdom of civilizations that came before us and the innovative potential of awareness that has never existed in quite this form before. The cosmic clock continues its countdown, but for the first time in cosmic history, the consciousness patterns it's counting down to are themselves evolving in real time, potentially changing the very nature of what cosmic transcendence means. So, where does this leave us? Standing at the edge of a mystery that stretches back 200,000 years and forward into an uncertain future. We've traced the scattered evidence from anomalous artifacts buried in ancient rock to genetic memories encoded in our DNA. we've explored how an advanced civilization could rise, flourish, and vanish so completely that only whispers remain. Most importantly, we've discovered that this isn't just ancient history. It's a warning, a blueprint, and perhaps our only chance to break the cycle. Whether we're the first intelligent society on Earth or the latest in a long line of cosmic experiments, one thing is certain: the choices we make in the coming years will echo across the same vast timescales that buried our predecessors. The question isn't just what happened 200,000 years ago, it's what happens next.